All right. Okay. I thought I did. All right. I just want to quote again. That just happens to be some of the verses this morning, but I want to look at them from a little different angle. The way the title of this talk is called Math Problem. Now, faith is the substance of things hoped for, the evidence of things not seen. For by it the elders obtained a good report. Through faith we understand that the worlds were framed by the word of God, so that things which are seen were not made of things which do appear. Faith, as we talked about this morning, is the evidence of things which are not seen. And I talked a little bit this morning about how we can believe in things, that we all believe in things that we don't see. But the question is, I don't see them, but can I believe in them? Can I prove these things that I believe in but cannot see? In some cases, I don't think so. But I mean, so what? Have you ever thought about all the things that you believe in, things that you are absolutely sure about, utterly convinced of, and yet really cannot prove? I want to read you a quote here. I got it out of Harper's Magazine. It's by a man named Stanley Fish, who's a English professor at Harvard or Yale, or I think he's a Marxist. I think the only Marxists left in America are English professors at Harvard and Yale. But I want you to listen to this quote from this man, because it's a fascinating quote. I guess I got it out of Harper's, if you're familiar. Some of you might not know Harper, some of you do. I've been reading it for 28, 29 years now. Excellent, man. Very left-wing politically, left-wing in everything, but it's just very well done, and I read it religiously. Here's Stanley Fish. Listen to what he's saying here. In order to assert something and mean it without qualification, I of course have to believe that it is true. But I do not have to believe that I could demonstrate its truth to all rational persons. The claim that something is universal and the acknowledgement that I couldn't necessarily prove it are logically independent of each other. The second does not undermine the first. Did you catch that? Did you catch that? He's saying, I can believe in something, I can believe it's absolutely true, and yet it doesn't mean that I can absolutely or I can logically prove that's true, its truth, to other logical, rational people. I mean, I believe that the sun is going to rise tomorrow. In fact, I could say that I know the sun is going to rise tomorrow. But what real proof, real deductive, absolute, apodictic proof do I have that the sun will rise tomorrow? Really, all I have are my past experiences. My past experiences of every morning the sun's going to rise, and the little bit that I know about gravity. But just because something always happens with unceasing regularity doesn't automatically mean it will happen in the future. The philosopher Bertrand Russell, whom I'll be talking about more, tells a story about a farmer. Every morning, the farmer goes out to feed his chicken. So every morning he goes out and throws the food down, and every morning the chicken opens its mouth, or whatever chickens do. I don't know. I've never been around chickens. Closest I get to a chicken is an egg. But every morning he'd throw out, so every morning the chicken got used to the farmer coming out and throwing out the food. And every morning he did it till one day the farmer, instead of coming out and throwing out the food, came out and chopped its head off and made breakfast or lunch out of them. Just because something always happens in the past doesn't mean it will happen in the future. Couldn't some unknown factor within the law of gravity cause the sun not to rise tomorrow? And if you believe in God, and if you believe that God is over, above, and beyond all the laws of nature, couldn't God, if he wanted to, stop the sun from rising in the sky? And meanwhile, I'm not aware of any logical contradiction in asserting that the sun won't rise. So the point is, though I do know that the sun will rise, or I may ask the question, do I know absolutely that the sun will rise? Or do I just believe that it will? There is a big distinction in philosophy between, they call it the knowledge-belief distinction. What is the difference between knowing something and believing something? And there is also a problem called valid justification, which means that you can have very good reasons for believing in things that are absolutely wrong. For instance, suppose you were a native living 500 years ago in some equatorial rainforest somewhere in the middle of Latin America. Okay? And suppose you believe, somebody told you that it was possible for water to become so hard you could walk across it. Now, you would have very, very good reasons for not believing that. You've never seen that happen. Chances are you don't know anybody that has seen that happen. Chances are anybody you've known has never seen that happen. I mean, you have very good reasons for believing that it would be impossible for water to be hard enough that somebody could actually walk across it. Or suppose you were raised in a village somewhere out in Afghanistan, and from the time you were an infant, you were taught the glories of jihad. And you were taught that when the time comes, Allah's going to call you, and you're going to have to kill yourself for Allah, and you will get blown up, and you will instantly be transported to heaven, and with 72 virgins. Though I heard there's some debate in Islam whether those words are virgins or whether the word is really raisins, not virgins. But I don't know. I'm not going to get into that. The point is, you'd have very good reasons for believing that, even though it's wrong. So if people can have valid justification for believing in things that are wrong, where does that leave us? Is there anything that we can know absolutely for sure, but not only know it, but have concrete proof for our beliefs? Is there anything? Well, what about mathematics? Many of the philosophers of the 20th century, many of the great ones, came from a mathematical background, because so much in the quest of philosophy is the search for certainty. People want certainty. They don't want contingency. And the idea was, in mathematics, you could find certainty there in ways you couldn't find it anywhere else. You know, things like 2 plus 2 equals 4. Things like the angles of a triangle equal 180 degrees. Or even strange things like that I've never understood is how you could take a negative number and you can multiply it by another negative number and get a positive number. I have never understood that. You take a -3 and you multiply it by a -5 and you get a positive 15. Don't ask me. I don't know how it works. And yet you do, and you know that -3 times -5 equals 15, or that 2 plus 2 equals 4, so forth. I mean, these are rock-solid contingents. These are rock-solid truths that exist apart from the contingencies of human weakness, the fluctuations of human subjectivity. I mean, it doesn't matter whether a mathematician gets up in the morning and eats pork and beans, you know, or for breakfast, or has a doppio latte from Starbucks and goes to work. 2 plus 2 is going to equal 4. It doesn't matter whether you believe God created math or just discovered it. It doesn't matter. These are absolute truths. Anyway, again, that's my point. Mathematical truths are absolutely certain, right? I mean, in a world where we can't prove that the sun rises tomorrow, we really can't prove it, we can certainly prove the basic and great truths of mathematics. Religion is based on faith, on what you can't prove, but math is based on pure logic and pure proof, pure reason, right? Right? Wrong. It's not quite. Math isn't as provable as I once thought. And I find that realization utterly, utterly, utterly astounding, full of fascinating implications for me as a person of faith, as a person who is called to live by faith, as a person who is called to believe in things that I really cannot prove. But what am I talking about? You know, there's an old joke. A mathematician goes into a restaurant and he gets his bill and he adds up the numbers. My father was a mathematician and he always would do all the math, and people try to rip my dad off, you know, with the bills. He was the wrong one to try to do it with. And the mathematician gets the bill and he adds it up, and this is what he says. Well, the arithmetic looks okay, but I fear that the axioms upon which it is built might not be as solid as one would hope. Now you think, axioms might not be as solid as one would hope? Isn't that the whole point of axioms? To be solid? After all, math starts out with axioms, these fundamental teachings upon which all else is built. I mean, if you remember something from high school geometry, what is the definition of an axiom? We all remember high school geometry. Do you remember what an axiom is, how it's defined? Let me refresh your memory in case you forgot from high school geometry. This is the American Heritage Dictionary definition of an axiom. Quote, self-evident principle or one that is accepted as true without proof as a basis for an argument, or it's a postulate. What did it say? Accepted without proof? In other words, you have to build your entire system of math on axioms, things that you have to accept without proof. You know, building a building on a foundation, it's like building how would you like to be in a 20-story building? Built on a foundation that you really don't know is solid or not. Solid or not. In a building, that would be a little scary. But math, ultimately, building something without proof, I mean, that sounds a little bit like faith. Taking it without proof. It's one thing, religion, but to take math on faith, except something like mathematics without proof, well, that's basically what it is. It begins with these axioms that you cannot prove. Now, it gets even more difficult when you deal with numbers. First of all, do mathematical truths even really exist? There's a great debate in the mathematical community or among philosophers of mathematics about, do numbers even exist at all? I mean, can you just, what is a 2? Have you ever just run into a pure 2? I mean, what does it look like? What color is it? How big is it? Does it have shape, color, body, extension? Or a 10? Anybody's ever seen a 10 out there? I mean, just a pure 10? I mean, a real one? Is it larger in size and bigger in mass and all that than a 2? Now, you can think of 2 dogs. You can think of 10 fish. Or you can even think of the concept of 10. But just because you think of a concept doesn't give it reality. I can think of a red-haired unicorn that's got the name Green Bay Packers, tattooed on its side, all right? Packers. I originally had here the New England Patriots, but in lieu of what happened yesterday, we'll call it the Green Bay Packers. So you got I can think of a unicorn, a red-haired unicorn with the word Green Bay Packers tattooed on it. I could think of the concept, but it doesn't make it real. I've never seen one any more than I've seen a 2. Now, a 2 and a 10 is one thing, but what do you do when you start thinking of a -6, okay, or a -12? I mean, do these things exist? Do they have some kind of reality? I mean, come on. Or what about what they call, I find this fascinating, irrational numbers? Irrational numbers, such as the famous square root of 2, which comes out to 1.414213 and on and on and on forever. It goes on forever. Does that exist? Is that something that's there? And what about any one of the supposed infinite number of irrational numbers that exist between 0 and 1? Ideally, any mathematician, I think, could prove to you that there's an infinite number of irrational numbers between 0 and 1. Fine. But are they real? Do they exist? This has been a massive debate among mathematicians for centuries. Okay, do they exist? Are they out there and we discover them, or do we create them? But see, then here's the other question, though, which is even more fascinating. If numbers don't really exist, how come they explain the world so well? Okay? How come the math works so well in explaining things? How come without math we couldn't fly jets? It takes an awful lot of mathematics to fly a jet, or to build a bridge, or to explain the motion of stars. Have you ever looked at a physics book? It's math, it's numbers, or astronomy books. I remember when I was young, I used to think I wanted to be an astronomer. And I thought, oh, I'd just sit there and I'd take my telescope and I'd look up at Pluto and I'd muse about them, the motions of Pluto in the sky and all that. Then got a little older and started looking at astronomy books, and it was all mathematics. That's not what I wanted to do. How strange it is. Some argue that numbers don't even exist, and yet how strange it is that something we don't even know if it exists is so good in explaining, or at least describing, what we do know exists. One of the greatest mathematical philosophers of the 20th century, Bertrand Russell, whom I quoted earlier, once said, mathematics can be defined, quote, as a subject in which we never know what we are talking about, nor whether what we are saying is true. It gets worse. Let's go back to good old geometry again. Good old geometry. Now, we all know of Euclid, and we've all studied Euclidean geometry in high school. And we all know that the angles of a triangle equal, of course, 180 degrees. And that two parallel lines, is that making a funny noise, or is it just me? It sounded. Maybe I just stay here. We know that angles equal of a triangle, always 180 degrees, parallel lines, never meet, and of course, the shortest distance between 2 points is a straight line. I mean, geometry is about as basic and fundamental as you can get, because it's based ideally on pure logic and reason. I can remember in 9th grade geometry, I remember the teacher telling us that when you get done with our geometry course, you're going to understand how to live more logically and reasonably, because you are studying geometry, because it's all logic and reason. And well, for 1,000 or so years, the whole Western intellectual world accepted this Greek doctrine that the axioms of Euclidean geometry and so forth, in general, were truths about the physical world. Truths that were so clear and evident that nobody in their right mind would doubt them. How are you going to doubt that the shortest distance between 2 points is a straight line? Any clown can see that. And because the axioms were true, the theorems and all that followed from them that were logically deduced, they were deduced from them, had to be true as well, because they were based on indubitable, absolute things that had to be true. I mean, again, the shortest distance between 2 points is a straight line. That's as clear as can be. Only a fool would dispute something so obvious. Well, there's a problem. A funny thing happened in the 18th century, in the 19th century, rather. It was called non-Euclidean geometry, in which mathematicians developed a logically consistent geometry, as logically and consistent as Euclidean geometry, in which, guess what? Parallel lines did meet, in which the angles of a triangle weren't 180 degrees. They, depending on the kind of geometry, they were more than 180 degrees or they were less than 180 degrees. And it was a geometry where the shortest distance between 2 points wasn't a straight line. It was a geodesic. It was a curved line. Non-Euclidean geometry. It was it was coherent and as logical as Euclidean geometry. Now, at the time the folks first started doing this, they thought, all right, this is interesting stuff. This is fun. This is what geometers like to do, mathematicians like to do. But of course, we know it has nothing to do with the real world. Well, it turns out that along comes Albert Einstein, and it appears that these non-Euclidean geometries fit reality better than the geometry of Euclid. And that's because Einstein's general relativity showed that space is curved, that it's not this flat Euclidean stuff that you get, these flat planes and so on. And so the shortest distance between 2 points is really not a straight line because it's not the way Euclid taught. Space is curved, and therefore the geometry is different than what was taught in Euclid. Because to think about it, when you fly, for example, we'll give you a quick example. When you fly, say, from New York to Europe, you don't fly. You want to get there as shortest distance possible, do you? Do you fly straight across the Atlantic? They don't do that. What do? They fly up north because it's shorter to go this way than to go straight across. Because in a curved space, in a curve, the shortest distance between 2 points is not a straight line. It's a geodesic. Now, the point, though, is that the foundation of geometry, centuries and centuries of what was considered absolutely immovable in the 19th and in the 20th century was completely kicked out. Now, it gets even worse. There was a German mathematician named Gottlieb Frege. And Frege had this funky idea. He thought, it might be a really good idea if we could put mathematics once and for all on a logical footing. I mean, after all, is it unreasonable to think that mathematics should be logical? So Frege spent years of his life trying to formalize math, trying to put it on a logical footing. And he spent years doing it, and he thought he had done it. He thought, wow, I've been able to show once and for all that mathematics is absolutely logical. And when he got done, he sent his work to a young British aristocrat who I've already mentioned by the name of Bertrand Russell. And Bertrand Russell read Frege's life's work, and he said, well, I'm very impressed, and you've done some very good things here. He says, however, I have just one question. Just one question I want to ask you. And with that one question, boom, he kicked out the entire foundation of Frege's work. And even Frege was forced to admit that everything he had worked on was completely nullified by what this one question that he asked. And I'm not going to try to get into it because I can't explain it all in detail, but I'll give you the principle. It basically comes down to what is often known as the self-referential problem. And let me give you one of these little word things that people play with. The barber of Seville, or I guess Sevilla, I guess that's how you pronounce it. The barber of Sevilla shaves everyone who doesn't shave himself. Okay? simple statement. If you don't shave yourself, then the barber of Sevilla shaves you. Now, here's the question. Does the barber of Sevilla shave himself? Think about it. If he doesn't shave himself, then he has to shave himself because he shaves everybody who doesn't shave himself. But if he shaves himself, then he can't shave himself because he shaves everybody who doesn't shave himself. Now, that might, if you think about it, that might sound like a silly little word puzzle, but we have here as a foundational paradox of all knowledge, and this really strikes at the heart of all knowledge, because ultimately everything becomes self-referential, and it becomes tautological, and you end up saying X is X because X is X, and you just go in a circle. And this got even worse with the man who's really kind of my hero. His name is Kurt Gödel, Godel. And he showed that there are inherent limits in whatever we could prove mathematically. Gödel, with his incompleteness formula, in the 20th century, he proved this. He's a very strange little man. He ultimately got convinced that people were poisoning him, and he ended up starving himself to death. But his incompleteness theorem is considered one of the most foundational intellectual achievements of all history. In other words, he showed that you can't utterly prove the truth of mathematics. You know, he showed that with any given system, there will always be certain statements and propositions within the system that you cannot prove. Now, you can go outside the system and start new propositions, and with those propositions, then prove what was in the system below it. But then how do you prove your new propositions? You can't prove them within the system. You have to go outside the system and prove it. And it goes on, and it ultimately showed in the end that even most basic mathematics remains essentially incomplete, and so that no one can ever be certain that the axioms of arithmetic will not contradict each other. In other words, even in something as rigid and logical as math, there are basic aspects of it that just can't be proven. And I find this incredibly relativary, am I saying the word right? Revelatory. Okay, that's right, huh? I guess I'm in the wrong place to ask, I find it incredibly relative, whatever. I find it amazing that even cold, hard math, supposedly the foundation of all certainty, the one thing you can know with absolute certainty, comes with intrinsic and inescapable contingencies. In other words, you can believe these things, you can have good reasons to believe these things in math, but you ultimately can't prove it. It's fascinating. I read a fascinating little book called The Loss of Certainty by a fellow named Morris Klein. If this is something you're interested in, The Loss of Certainty, Morris Klein. And in the book, he writes this, quote, talking about the work of Kurt Gödel, or Gödel, I think it's pronounced, G with the umlaut, the O with the umlaut, Gödel, G-O with the two dots, D-E-L. This is what he said. The one distinguishing feature of mathematics that might have claimed in this century the absolute certainty of its results could no longer be claimed. And I mean, I just found that absolutely astonishing. Math! We're talking about math here. Now let me read you another quote. This is Bertrand Russell. This is amazing. This is Russell. He says, quote, I wanted certainty in the kind of way in which people want religious faith. I thought that certainty is more likely to be found in mathematics than elsewhere. But I discovered that many mathematical demonstrations, which my teachers expected me to accept, were full of fallacies, and that if certainty would indeed be discoverable in mathematics, it would be in a new field of mathematics, with more solid foundation than those that had hitherto been thought secure. But as the work proceeded, because he spent 20-some years working on this, but as the work proceeded, I was continually reminded of the fable about the elephant and the tortoise. Having constructed an elephant upon which the mathematical world could rest, I found the elephant tottering and proceeded to construct a tortoise to keep the elephant from falling. But the tortoise was no more secure than the elephant. And after some 20 years of very arduous toil, I came to the conclusion that there was nothing more that I could do in the way of making mathematical knowledge indubitable. Close quote. I don't know you, but this gives me the shivers. He's saying he tried for 20 years to make math certain, and he couldn't do it. And I read something a while back where somebody said they have pretty much, mathematicians, they pretty much have given up on the whole project. And what is the project? Simply to make math absolutely certain, absolutely logical. And now, folks, we're talking about mathematics here. We're talking about numbers. So basically, this to me, it's unbelievable. Now, what is the point in all this? You're probably wondering, what is the point in all this? Well, I think you probably can figure where I'm going. My point is simple. If something like mathematics cannot be proven, if something like mathematics to a certain degree has to be taken on faith, if it's something that you can believe but cannot ultimately prove, then I'm not going to get all worked up and all bent out of shape that I can't prove the existence of God, or that I can't prove the death of Jesus in my behalf. That is because I can't prove them. If I can't prove them, then what? I've got to take them on faith. Yet you have to, but you have to take math, something like math, on faith as well. So if you got to take math on faith, how much more so some of the things about God? I like this quote from John Polkinghorne. He's a mathematical physicist, and he's an ordained priest in the Church of England. And listen to this quote. If we cannot even prove the consistency of arithmetic, it seems a bit much to hope that God's existence is easier to deal with. Interesting. He caught exactly the point that I'm trying to make. I can't prove that parallel lines never meet, much less that God exists, or that Jesus died and that by my faith in him all my sins are forgiven, and that I can stand fully pardoned before him. How can I ever, quote, prove it? I can believe it. I can be sure of it. I can live my life and base my life on it. But can I prove it? Or do I have to even prove it? Sure, I can prove some things. Sure, I can't, but again, so what? If I can't have absolute proof about math, then I'm going to reject belief in God because I can't absolutely prove it as well. I'm going to reject Jesus because I can't prove the resurrection or the second coming. Sure, I can't prove some things, but I can be utterly certain of them. Goes back to that quote I read in the beginning from Stanley Fish. You can be absolutely certain of things. You can believe them. You could be convinced they're universal. But it doesn't mean that you can prove them to other people. And one doesn't contradict the other. Something could be absolutely true that you can't convince somebody else of, and it doesn't contradict. It could still be absolutely true even if someone else doesn't believe it, even if you can't prove it to them. And yet you can still believe it and still have good reasons to believe it. And see, this is the point. I have very good reasons. Very good reasons. And I think one of my talks I'm thinking about giving is called Why I Believe in God. I might even do that tomorrow. And I have good reasons for what I believe. But good reasons are not the same as proof. Nor do they need to be the same as proof. See, I'm not totally even sure, and again, this is where I do read a lot of philosophy, and I don't recommend it to everyone because it can really mess your brain up, okay? It can really, my wife is convinced I fried my brain with all this stuff, But it's like, you can believe in things, but, I am not totally even sure what it means to even prove something. I'm not even convinced we even know what a proof is. In fact, if you really get into it, when you talk about something as true, there's a whole field of philosophy that argues, what do you even mean when you say something is true? There are whole different theories about what it is to say something is true. So if you can't even agree on what it means when you say something is true, how do you ultimately prove it? But again, the point is, I can believe in things. I can live my life for things. I can dedicate my life. I can even be willing to give my life for things that I can believe, that I can be certain of enough to where I, live my life for them or die for them, that I don't necessarily, or I can't necessarily prove. And again, for people who are called to live by faith, if we could prove everything, where's the faith element? Where's the faith element? It'd be like I'm saying, trying to find an example. I got it in my head here. Give me a second. It's there. It's somewhere in there. I know. It's like, forget it. Forget it. It's there, but I'll mess it up, so I'm not going to go into it. I don't want to get it right. I don't want to, butcher it when I get it out. So, come on, it's right there. This is age. Forget it. I think of the story of doubting Thomas. I'd like to close with that one. It's in John 20, 27 through 29. Then said he, I'm not going to, the story. He's not going to believe it until he sees it. I guess I could have even used that this morning for my talk. Then said he to Thomas, reach hither thy finger and behold my hand, and reach hither your hand, and thrust it into my side, and be not faithless, but believing. And Thomas answered and said unto him, My Lord and my God. And Jesus said unto him, Thomas, because you have seen, you have believed. Blessed are they that have not seen, yet have believed. Yes, there's a lot that I haven't seen. There's a lot that I don't understand. And there's an awful lot that I cannot prove. But when I discovered, much to my amazement, that how much mathematics, ultimately, that's right, yeah, they're getting it, yeah. How much mathematics ultimately can't be proven. It's so what? So what? I can believe in things that I haven't seen and things that I don't understand. But I thank God for the gift of faith, for belief in what I don't fully understand, and for belief in what I can't necessarily prove. Okay.
Shall we rise for a closing song?